Saxon Algebra 1, Lesson 66. We are going to pick up where we left off in Lesson 65. Well, technically, remember in 65 we learned to add radicals, and then we did this weighted average stuff where we were professors figuring out our student grades. We're not going back to that. We're going back to adding radicals. Remember, the rule was that the radicals have to match in order for us to be able to combine the coefficients, right? Just like letters have to match. And if they don't match, remember this one? Remember, nothing matched. So we just said, okay, that's the answer. It's done. All right, that is the rule, tried and true. I'm not going to change that at all. But what I am going to do is throw another little curveball in there for you. What about something like this? Okay, we've got an addition problem. So we go, okay, we can't have pigs running back and forth between houses. That's not a deal when you're adding. That's only multiplying. Here, we can only combine them if the numbers inside the radicals match. Clearly, that is not the case. 18 and 8 do not match. So, at first we get excited and go, let's just box it. We're done. There's nothing we can do. But then we notice, wait a minute. These are not prime numbers. Notice that in this lesson, when we were adding, they were all bitty little prime numbers, right? 3s and 2s and 5s were mostly what we had, yes. Those are prime numbers and they can't be simplified. But these numbers are composite numbers, which means we can, pardon the expression, we can pull pigs out of these houses and rewrite them. That's technically called simplifying the radicals. Let me show you what I mean. The first thing we want to do is write a prime number tree. What multiplies to give me 18? I think of 9 and 2. 2 is prime. 9 breaks down into 3 and 3, right? So that means that the square root of 18 is equal to the square root of, I'm going to put these in here in order, 2 times 3 times 3. These are the same, right? And remember, a pair of pigs inside the house can jump out and become a single pig outside. So this one simplifies to 3 times the square root of 2. I said 2, but I wrote 3. So a pair of pigs inside equals a single pig outside. That's the rule. And the 2 was left over, so that's what we have. Oh, okay. Well, 2 still doesn't match to 8, so we're done, right? No. Sorry. 8 is 4 times 2. 2 is prime. There we go. Now it's prime. That means we can write square root of 8 as the square root of 2 times 2 times 2. And once again, there's a pair of pigs. They can jump out and be 1 on the outside. And we're left with that third 2 on the inside. Makes sense? Now look what happens. When we simplify the radicals, now they match. Oh my gosh, John is a magician. He made this all work out so that now our radicals match and we can happily add them. 3 plus 2, it's 5 square root of 2 is our final answer. So we simplified the radicals before we could actually add them, right? We were trying to add them, but we had to simplify them first and then it all worked out. And the good news is John is our friend, and he will make that work for us. Let's try another one. Ready? Now this one has got, oh no, this one's only got 2. I was looking at the third one. Ready? What I'm going to do this time is I'm going to leave myself some room up here to simplify. So I don't, whoops, this should be 75. I don't want to have to write this out so much. So I'm going to show you a slightly faster way to do it. Okay. 27, I'm going to go down to figure it out. 9 times 3, and then 9 breaks down to 3 times 3. So I'm going to write this as 3 times 3 times 3, all in one line there, right? The 8 is still there. I'm just not writing that part over. Okay, no, let's do it this way. This is even better. Instead of making a separate pig house, just write it inside the same house. 75, let's see, I always think of quarters. That's 25 times 3, and 25 breaks down. This I like better. Let's do it this way, where we'll write the set of pigs inside the existing house. 3 times 5 times 5. Okay, this 3 comes out. Instead of just writing it here, what we do is we multiply it against the pig against the number that's already out there. All right? So we brought out a pair of 3s inside equals a single 3 on the outside. We multiply at 8, so we get 24. And then what's left on the inside? That last 3. That looks pretty different, doesn't it? Okay, let's try this one. We've got a pair of 5s in here. We bring them out as a single 5 on the outside. We multiply it by the number that's already there. We're subtracting this time. So that'll be 15. And then what's left inside? Just a 3. Oh, they match. John. 24 minus 15 is 9 square root of 3. That's why these problems are fun, is because many times they'll come out to match and they're cute and they're just rewarding and satisfying and fun. Did I get this right? Yes, this one's right and this one's right. Okay, let's try one more. And then we're going to switch it up ever so slightly. In this one, we have 3 chunks of numbers. So I'm going to spread them out a little bit more. Square root of 27 minus 3 square root of 18 minus 6 square root of 45. Okay, as we do these prime factorizations over and over and over again, you'll get better and better at them. When you're good enough that you don't have to write out the factor tree, you can just go right to this. Like, I know 27 is 3 cubed, so I'm just going to write 3 times 3 times 3. I don't have to go through the exercise of that, okay? There's a pair of 3s. I pull them out. There's nothing out here, so this is going to become 3, just the 3 that came out, square root of 3. Minus, okay, let's try this one. 18 is 2 times 9, and 9 is 3 times 3. Okay? This is wrong. This is 45. Sorry. Yeah, it's 45. Okay, I've factored this one. Here I can pull out the 3s. I'm going to multiply them by that 3, so I'm going to get minus 9. And this is all that's left. Square root of 2. Okay, those don't match, do they? Okay. That's okay. And then this one, 45, let's say I can't think of how to do that one, so I'll do it. It's 9 times 5. Oh, and then 9 is 3 times 3, right? So this is going to be 3 times 3 times 5. I pull out the 3s. They come out here. They multiply by the 6. So then I get minus 18. And what's left? Square root of 5. All right, so I simplified these, and it looks really good, but nothing matches. But that's okay. This is the right answer. Square root of 3 times 3 minus 9 square root of 2 minus 18 square root of 5. We can't go any further in that problem, but at least we simplified each one of the radicals, and you know, they look pretty good, right? Okay, so that is some practice in simplifying radicals when we're trying to add them, right? Now what we're going to do is talk about what about if we have some really crazy big numbers, like 50,000. I want to find the square root of that. I do not, you guys, want to list all of the prime factors because there will be like a billion 2s, won't there? I don't want to do that. And a billion 5s. No, no thank you. That's hideous. I don't want to. I want to make this as simple as possible. So what I recognize is, oh wait, I could write this as 5 times, oh here, let me put it in the same one. 5 times 10,000, right? That's easier. That's true. And 10,000 I can break into 100 times 100. How do I know that 100 times 100 equals 10,000? Because I count the zeros. I want there to be an even number of zeros in each number. So 10,000, I look at it and go, okay, that's got 4 zeros. I can divide that into 2 groups of 2, and then I'll give each of the factors 2 of those, right? So now my factors add up to 4 zeros, just like my original number, and I can rewrite this as 5 times 100 times 100. Now I can pull out this pair of pigs without having to go to the trouble of writing out all the prime factors. All right, so this becomes 100 times the square root of 5. That's my final answer. That's correct. Okay, so we're gonna play with these numbers with 1 and zeros. We'll take the lead digit off because that's not helpful to us, and then we'll break these apart by separating them into equal groups of zeros. Let's make it harder. This one is 500,000. All right, we'll do the same thing. We'll make it 5 times 100,000. Oh, wait. And so we'll do the same thing here. We'll count the zeros, but wait a minute. 1, 2, 3, 4, 5. That's an odd number. Okay, so we're going to regroup this one more time. We're going to give one of the zeros to the 5. So that'll be 50. And then we'll split the even numbered into 2 equal groups. So that means our answer is 50 times 100 times 100. Now we can pull the 100s out. 100 on the outside. That leaves us with 50 on the inside. Now this we have to pay attention to because that doesn't look quite done, does it? That is equal to 25 times 2. And I can split this into 5 times 5. So I can write this as 2 times 5 times 5, which means I can pull out a pair of 5s, multiply it by this, and my final answer will be 500 times the square root of 2. That's my final answer. Now, that took a few extra steps, but now that we know the rule, we'll count the zeros in the beginning, right? We won't make this mistake of setting this up with an odd number of zeros. In the beginning, we'll count the zeros. If it's an odd number, we'll give one of the zeros to that lead digit, and then we'll be able to break those apart smoothly and evenly. Let's try another one. We have 2 more, I think. Yes. So we can practice using our shortcuts, so this doesn't take us a week. Example, okay, don't freak out, but look, 66.6, it's 666. I don't really believe that's Satan's number. I believe that Satan is real, but I don't believe that he lives in numbers, so I think we're okay. I'll bless it just the same here. Jesus is protecting us. Okay, so now we've learned our lesson. We know that we count the zeros first and figure out if they're odd or even. 1, 2, 3, 4, 5, 6, 7. Aha, they're odd. So he's going to be by himself, 40, and then each of our other numbers will have 3 zeros. So that's 1,000 times 1,000. Okay, now we can pull those out. And what I'm going to do is before I even go further, I'm going to pull that out, and we're going to have 1,000 on the outside. There's nothing outside currently. 40, I know, is going to break down because it's going to be 2 times 2 times 10. I'm kind of cheating in the way I do this. But I know I'll be able to pull a pair of 2s out as well. So these will come out, and they'll combine with that 1,000. See how I'm just making little notes to myself and circling things so I can see? So what that means is that this 10 will be left inside. There's no perfect squares in that. But my final answer will be 2,000, right? 2 times 1,000 times what's left? Square root of 10. These are kind of fun, aren't they? You get the secrets of how to sneakily break them down. Okay, and one more. Simplify. Ready? It's a big number. 700 million. 700 million. Okay, I know I'm going to break it apart. Let's count the zeros. 1, 2, 3, 4, 5, 6, 7, 8. Aha! So what that means is that we have an even number of zeros. So it's going to be 7 times, what did I say, 8? So each of our smaller numbers will have, oh wait, that's only 3 zeros. There's 4. 1, 2, 3, 4. So it's 7 times 10,000 times 10,000. So now this I know is not going to be able to be broken down. That's a prime number. But we have the pair of 10,000s. They'll come out. And our final answer is 10,000 times the square root of 7. And now I hope you feel extremely smart. Because look at these big numbers that we can easily simplify and find the roots of. Yay! Again, in this one we weren't adding the numbers to anything. We were just practicing simplifying really big numbers in square roots, roots of large numbers. In the other one, we were doing it as part of an addition problem. But here, John said, let's just practice simplifying. We don't need to add them. Okay, that's lesson 66. We're halfway through the week. Well, I am. You still have to do all the homework. But we're charging through another one, you guys. Fantastic job. We've got Groundhog's Day coming up. So I don't know what you're hoping for. Whether you want the groundhog to see his shadow and go back in the ground so we have more winter, or if you're thinking he should come out on a cloudy day. I always thought that was so counterintuitive when I was a little kid. If it's sunny, shouldn't the groundhog think it's spring? It made no sense to me. Now I know it really just doesn't make sense. You don't have to beat yourself up thinking about it. All right, that's enough of that. You guys just got another chapter of my autobiography. Thank you. Either that or you're my therapist. I can't decide. But anyway, I'm going to go now. Lesson 66 is done. Goodbye.